The Tyrannosaurus rex, the most iconic dinosaur of all time, has always been shrouded in mystery. We marvel at its size, its teeth, its sheer power. But where did this tyrant king come from? How did it evolve into the apex predator we know and fear? A groundbreaking new study published in Royal Society Open Science may hold the answers. And the findings are surprising. It seems the T-Rex's family tree has roots not in North America, as long believed, but in Asia. This revelation comes from a meticulous analysis of tyrannosaur fossils from around the world. Scientists have long recognized similarities between T-Rex and smaller tyrannosaur species found in Asia. However, this new study provides the most compelling evidence yet of a direct evolutionary link. By comparing the skeletal features of these Asian tyrannosaurs with those of T-Rex, researchers have been able to trace their lineage back to a common ancestor that roamed the Earth millions of years ago. The picture that emerges is one of ancient migration, a tale of dinosaurs on the move. Over 70 million years ago, during the late Cretaceous period, a group of tyrannosaurs embarked on a transcontinental journey. They likely crossed the Bering Land Bridge, a landmass that once connected Asia and North America, in search of new territory and hunting grounds. This was not a one-way trip. Fossil evidence suggests that tyrannosaurs and other dinosaur groups migrated back and forth between the continents multiple times during the late Cretaceous. This constant movement and intermingling of species created a dynamic evolutionary melting pot. These Asian ancestors of T-Rex were not the colossal predators we know today. They were smaller, swifter, and perhaps even feathered, but they possessed the seeds of greatness, the evolutionary potential that would eventually give rise to the tyrant king. As they spread across North America, they adapted to new environments, prey, and competitors, gradually evolving into the larger, more powerful forms we recognize today. This migration from Asia to North America coincided with a period of significant global cooling around 92 million years ago. Temperatures plummeted, and the world became a much colder place. While this might seem like a challenge for reptiles like dinosaurs, it actually proved to be a boon for tyrannosaurs. As other dinosaur groups struggled to adapt to the changing climate, tyrannosaurs flourished. They underwent a remarkable growth spurt, evolving from small, agile hunters into the colossal predators that dominated the late Cretaceous. The reasons for this growth spurt are complex and still being debated by scientists. One theory is that the cooling climate favored larger body sizes, as larger animals are better at retaining heat. Another possibility is that the extinction of other dinosaur groups opened up new ecological niches for tyrannosaurs to exploit. Whatever the cause, the result was clear. Tyrannosaurs thrived in the cold while many of their competitors went extinct. The idea of a cold-adapted T-Rex might seem strange, almost counterintuitive to our usual perceptions. After all, we typically picture dinosaurs as inhabiting lush tropical environments, teeming with life and greenery. However, fossil evidence suggests that some tyrannosaurs, including close relatives of T-Rex, lived in environments that experienced freezing temperatures and even snowfall, challenging our traditional views. This raises intriguing questions about their physiology and adaptations, pushing scientists to rethink how these creatures survived. Could T-Rex have had feathers for insulation, like some of its smaller tyrannosaur cousins? Feathers could have provided much-needed warmth in colder climates. Could it have been warm-blooded, or at least partially warm-blooded, to cope with the cold? This adaptation would have been crucial for survival in such harsh conditions. These are areas of ongoing research, and the debate continues among paleontologists and researchers. Some scientists believe that feathers, which are found in many other dinosaur groups, could have been present in juvenile T-Rex, or even retained in adults for display purposes, adding another layer to their complex biology. Others argue that the massive size of T-Rex would have made feathers unnecessary for insulation, as their large bodies could retain heat more efficiently. Similarly, the question of warm-bloodedness in dinosaurs is a complex one, with many facets to consider. While there is growing evidence that some dinosaurs were indeed warm-blooded, the jury is still out on T-Rex, leaving room for further discoveries and discussions. Megaraptors, cousins from the east. The story of T-Rex's Asian origins is just one chapter in a much larger saga, the story of the rise and fall of the dinosaurs. This grand narrative spans millions of years and countless species, each with its own unique tale. And within that saga, there are many other fascinating characters, dinosaurs like the Megaraptors. These creatures add depth and intrigue to our understanding of prehistoric life. These fearsome predators were close relatives of tyrannosaurs, and they too have a connection to Asia. Their lineage provides crucial insights into the evolutionary pathways of predatory dinosaurs. Fossil evidence suggests that Megaraptors originated in Asia around 120 million years ago, during the early Cretaceous period. This era was a time of significant evolutionary experimentation and diversification. From there, they spread across the globe, eventually reaching Australia, South America, and even Antarctica. Their migration patterns reveal much about the ancient world's geography and climate. Megaraptors were characterized by their large size, powerful legs, and enormous claws on their hands, which they likely used for hunting prey. These physical traits made them formidable hunters in their ecosystems. They were among the top predators of their time, and their fossils have been found on every continent except Europe and North America. This widespread presence underscores their adaptability and success. Their widespread distribution and evolutionary success highlight the interconnectedness of the dinosaur world and the importance of continental drift in shaping the evolution of life on Earth. The movement of continents played a pivotal role in the distribution and diversification of species. A dynasty of domination, the evolutionary success of tyrannosaurs. The story of T-Rex and its Asian ancestors is a testament to the power of evolution, the ability of life to adapt, diversify, and thrive in the face of change. From their humble beginnings as small feathered creatures, they evolved into the apex predators of their time. Tyrannosaurs, as a group, were incredibly successful. Their dominance spanned continents and epochs, showcasing their adaptability and resilience. They ruled the northern hemisphere for over 100 million years, evolving from small, feathered ancestors into the largest and most formidable land predators the world has ever seen. Their size, strength, and hunting prowess made them the undisputed kings of their ecosystems. Their reign ended abruptly 66 million years ago, when a massive asteroid slammed into Earth, triggering a global extinction event that wiped out the dinosaurs along with 75% of all plant and animal species on the planet. This cataclysmic event reshaped the course of life on Earth, but their legacy lives on. The evolutionary lineage of tyrannosaurs can still be seen today in modern birds, their distant relatives. Tyrannosaurs, especially T-Rex, continue to capture our imaginations and inspire awe. Their sheer size and power, combined with their dramatic extinction, make them a perennial favorite in popular culture and scientific study. They remind us of the incredible diversity of life that has existed on Earth and the powerful forces that have shaped our planet's history. The story of tyrannosaurs is a story of survival, adaptation, and the ever-changing nature of life on Earth. And they serve as a reminder that even the mightiest creatures are not invincible, that extinction is a natural part of life's grand tapestry. Their story is a poignant testament to the fragility and resilience of life. Uncharted territory. The hunt for fossil treasures continues. The discovery of T-Rex's Asian origins opens up exciting new avenues for paleontological research. If the Tyrant King's ancestors hailed from Asia, then there are likely many more fossil treasures waiting to be unearthed in this vast and relatively unexplored region. The same holds true for other parts of the world, such as Europe and Africa, where dinosaur fossils are relatively rare, but hold the potential to rewrite our understanding of dinosaur evolution and biogeography. The hunt for these fossil treasures is a global endeavor, a collaborative effort involving scientists from around the world. It is a race against time, as erosion, development, and other factors threaten to destroy these irreplaceable remnants of the past. But it is a race driven by curiosity, by the insatiable human desire to understand our place in the universe and to unravel the mysteries of life's long and wondrous journey. Conclusion: rewriting the history of the Tyrant King. The T-Rex, once thought to be a purely North American icon, is now revealed to be a product of a global story, a testament to the interconnectedness of life on Earth. Its Asian ancestry adds a new layer of complexity and wonder to the tale of the Tyrant King, reminding us that the history of life is full of surprises. As we continue to explore the fossil record and uncover new evidence, we can expect to rewrite the history of T-Rex and the dinosaurs many times over, each discovery bringing us closer to understanding these magnificent creatures and the world they inhabited.